Aloha and welcome. In this lesson, we're going to be talking about our serial ports. So let me bring up something here that is going to be useful. It's our handy dandy PDF file. And in here, you can see the section on serial communication. As always, our PDF does a pretty bad job of explaining concepts. So I'm going to bring up some more material and I'll link it down below for you to look at later. But first of all, let's go and take a look here. The components used for the first project serial print are going to be simple. It's just going to be your cable and your Pico. There's nothing necessary outside of that because all we're going to be doing is using the micro USB connector, which is itself a serial connector. So for related knowledge, it talks about serial communications here. Generally, it's referring to UARTs, the Universal Asynchronous Receiver Transmitter. There's also something called USARTs, which it doesn't really talk about, and that's the Universal Synchronized or Asynchronous Receiver Transmitter. So here, in talking about the UARTs, you've got essentially two different lines. You've got the receiving, the RX, and you've got the transmitting, the TX. And on the your transmit on your device will go to the receive on the other device, and vice versa. So before you do that, you need to have a universally agreed upon speed of transfer called the baud rate. This goes back a long ways. I remember when I used a phone line modem back in the old days, we used 9600 baud modems, and that's the same idea, the baud rate. It's your communication speed. So it shows in the next graphic the serial port on the Raspberry Pi Pico. As you can see, your computer has a COM port. You plug in through the USB-A, part of your wire. You plug in one end there, and then the other end goes to the UART. So that's plugging into the connector on your Pico, and that's a UART. So if we look at the picture here, simply put, this is your connector line, and this is where it goes. So that's an example of a UART on there. So we're going to open up the code for this. We're going to import time. Hold on just a second. And we're going to just do a print. And let me go ahead and bring that code up in VS Code. Give me just a second to pull that up. So it's in 073, or no, 081 serial print. So we're going to take a look at the first one, which is the, let's see, the serial print. And I'll close all these errors here. So as you can see, we're going to do an import of time just because we're doing a sleep. We're going to print out a message, and then we're going to say, while true, we're going to print a running time, and we're going to calculate the time, and we're going to sleep again. So this is going to be coming over the UART, and it's going to display on the actual system here. So when we go ahead and run this, you hit run, you'll see that it's printing out. So it's actually running this on Pico, and it's printing it over here on our system. So that's pretty cool. So this is one example, the most simple way of using a UART, and that's because it's what it's essentially doing here is printing it out on its default USB connection here. So believe it or not, this is the majority of what they had for the first lesson, but let me go down and show you a couple of things here in the lesson as well. So there are two serial port communications, UART 0 and 1. And you can find them over here. You've got your transmit on, or your receive on 0, and your transmit on pin 1. Then you go down and you've also got you can go and check, you've also got the UART 1 on pin 4 and 5. So that's going to be your transmit and your receive. So this is interesting because I just realized that they've reversed what they've got up here, and I'm wondering, we can check the schematics in a second. They're saying that your receive is 0 and your transmit is 1 here, but yeah, then they're saying down here that it's the reverse of that. So I don't know if I think that this is probably correct. Let's take a look. So here you got transmit on 0, or let's zoom in here. So if we look, we've got GP, yeah, GP0 is going to be your transmit. So it's transmit, receive, not, as they're saying up here, receive and transmit. They've got it backwards here. So keep that in mind. I didn't like this. They're getting into class UART here, so you can understand things about the ID, the baud rate, bits, parity, receive, transmit, stop, and everything. We're going to be using this later. So this is a reference really not for this one, but for the next chapter that's coming up, which is the 8.2. Don't worry about that for now. What I do want to show you is something that you'll find interesting, and that is there's this great source, and I'll put this in the video down below, or in the text down below, but this is a good explainer about your Pico serial communications. It talks about UART and USART, the differences between the two. Essentially, because USART is synchronous, you're gonna need a clock to actually synchronize your transmissions. UART doesn't use a clock to synchronize everything. They do use a baud rate for speeds, but they're not actually timing it off of the clock of the system. So it goes in and explains to you the difference between parallel. Parallel, you've got several different lines transmitting at once. It's faster, you can transfer more that way, but your serial interface, you're sending it bit by bit in one single line. And then it talks about different things that use serial communications. Your I2C, your SPI, and USB are examples that use serial communications. Then there's this concept of the UART frame. So UART frames, you've got your start bit, which is 1 bit long. You've got your data bits, then you've got your parity bits and your stop bits. And the way this works is generally your transmission or the GPI pin is going to be reading high. So you'll take your start bit, you'll have a start bit, and that start bit, you'll actually do the opposite. You'll bring it low. You'll have it start with a 0. Then you'll have your data bits, and that's going to be 5 to 9 bits. And then you're going to have your 0, 1 parity bits. And the parity bits are just a correction. So they help you, if you've got any loss of bits in transmission, your parity bits are going to reveal that. And then you're going to have 1 to 2 stop bits as well. And the stop bits are the opposite of what the start bit is. The start bit, it's when you pull it low, and the stop bits are going to return it to high. So you'll have 2 signals that are high, which specify it's the end of the frame. So they have an example of that here. You've got it high, and then when you start your frame, it lets you know by pulling it low, and then it's got the data that goes over these bits, and it's got 2 high bits in a row that let you know, hey, it's the end, and then you're out. So that's the main thing I wanted you to see. There's other information here. It gets into the pin layout and everything else, but that's as far as I really want you to go with this guide, because after that, they start going into Arduino stuff. So there's no need for that. We've got our own examples coming forward, but here's a nice little guide to understanding the UART that we really didn't explain in the PDF manual that we have. So that's it for this lesson. Stay tuned. We're about to jump into the next one. I'll see you there.